Hello friends, this video on P block elements part 16 is brought to you by examfear.com. No more fear from exam. The next important compounds for the nitrogen family is oxides of nitrogen. So in this we'll be studying dinitrogen oxide, we'll be studying nitrogen monoxide, we'll be studying nitrogen trioxide, nitrogen dioxide, nitrogen tetraoxide, nitrogen pentoxide. Let's study the first oxides of nitrogen, that is dinitrogen oxide. Dinitrogen oxide is nothing but N2O. Oxidation state of nitrogen is +1 here. It is colorless and neutral gas. It is colorless gas. It is also neutral, correct? So to prepare my N2O, what we do is we take NH4NO3 and we heat this, we get N2O and some water molecule. If you draw the structure of this N2O, this is something like this. This NN bond is 113 picometer and NO bond is 119 picometer, and the shape is linear. Let's draw the Lewis structure of this N2O. NO. How many valence electron? 5, 5 and 6. That is 5 plus 5 plus 6. That is 16 valence electron. We'll draw these electrons, will form a bond. So we have used 1, 2, 3, 4 electrons. So we are left with 12 electrons now. Now these 12 electrons we have to distribute among this nitrogen and oxygen so that all of these satisfy act octet. So if you actually draw this, you can draw 3 different structures for this. So in one case 6, 12 we have, right? 2, 4, 6, let's say 8, 10, 12. This nitrogen oxygen has 1, 2, 3, 4, 5, 6, 7, 8, octet is complete. This nitrogen has 6 plus 7 plus 8, octet is complete. This nitrogen has only 4. Since this nitrogen has only 4, what we can do is we can form a triple bond here between nitrogen and oxygen so that my nitrogen octet is also complete. So in that case, I'll get some structure something like this. Correct? These electrons move, 4 electrons move. So in this case, nitrogen has 1, 2, 3, 4 into 2, 8 electrons. This nitrogen has 8 electrons. This oxygen has 1, 2 and 6, 8 electrons. This is one possible option. The other possible options we have is we can actually get 2 electrons from this and 2 electrons from this. So in that case we get something like this. Here we'll have 1, 2, 3, 4, 5, 6 and 8 electrons. This nitrogen has 8 electrons, 4, and here you will have 4 electrons. This is another possible option. Another possible option is we'll get 4 electrons from this nitrogen, nitrogen 1, so that all will form octet. So we'll get something like this. So this will have 6 electrons, this will have 2 electrons now, and now if you see this nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen has 1, 2, 3, 4 bond, that is 8 electron. This oxygen has 6 plus 2 electrons, 8. All 3 possible scenarios, right? But out of these, let's see the charge. In this case, nitrogen will have how much charge? Nitrogen has 5 electrons, right? 5 minus 1, 2, 3, 4, 5, 6, 7. 5 minus 7 is minus 2. This one will have 5 minus 1, 2, 3, 4. 5 minus 4 is plus 1. This oxygen will have oxygen valence electron is 6. 6 minus 1, 2, 3, 4, 5. 6 minus 5 is plus 1. So that will be the charge distribution. In this case, we'll have nitrogen is 5. 5 minus 1, 2, 3, 4, 5, 6. That is minus 1. This nitrogen is 5 minus 1, 2, 3, 4. That is plus 1. This oxygen will have charge 6 minus 1, 2, 3, 4, 5, 6. Minus 6. That is 0. Again, this nitrogen will have 5 minus 1, 2, 3, 4, 5. That is 0 charge. This nitrogen will have 5 minus 1, 2, 3, 4, that is plus 1 charge. This oxygen will have 6 minus 1, 2, 3, 4, 5, 6, 7, that is minus 1 charge. So if you see, this is ruled out because it has more charge, -2 charge, +1 charge. So out of these two are the possible structure of N2O actually. These two are the possible structure of N2O, correct? And out of these two structures, I'll say probably this is more stable. Oxygen has negative charge, nitrogen has positive charge. Anyway, these two are the possible structure of N2O. Let's try to understand nitrogen monoxide is NO. Oxidation state of nitrogen is +2. This is again a colorless gas. And this is also neutral. Right? To prepare, what you have to do is you have to use NaNO2 and some FeSO4 and some sulfuric acid. React this, you get Fe2 SO4 whole 3 plus NaHSO4 and some water molecule, and you get some NO. This is my whole. If you want, you can write a balanced reaction for this. So I'll not spend time on balancing. This is how it comes out to be. Correct? If you want to draw the structure, this is the structure NO. The bond length is 115 picometer. And this is again a linear. So let's draw the Lewis structure. The Lewis structure is here is N, here is O. Now in NO, what is the number of, this has 5, this has 6, 5 plus 6 is 11 electrons. You draw a bond, you consume 2 electrons, you have 9 electrons left. 9 electrons you have to somehow distribute. Let's distribute 6 electrons here, 1, 2, 3, 4, 5, 6, minus 6, 3 is left, 3 we can put here. Now if you see, we are done with all the electrons, but oxygen has 1, 2, 3, 4, 5, 6, 7, 8, that is fine. Nitrogen has 1, 2, 3, 4, 5, that is not good, right? It has to have 8 or at least 7. So what we'll do, we'll transfer these 2 electrons, and these 2 electrons will transfer and form a bond here. So it will be something like this. This was already there, and these 2 are transferred electrons, the one you see, right? And you will get bond like this. Now in this case, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen has 1, 2, 3, 4, 5, 6, 7. Nitrogen has 7, oxygen has 8. This is the best you can get for nitrogen. So this will be the structure. So NO will be of this structure. Okay. If you want to see the charge also, you can see nitrogen will have charge 5 minus 1, 2, 3, 4, 5, that is 0. Oxygen will have charge 6 minus 1, 2, 3, 4, 5, 6, 0. So net charge is also 0 in both nitrogen and oxygen. So this is the structure we have. Let's talk about dinitrogen trioxide. Dinitrogen trioxide is my blue solid. This is how it looks. This is acidic. And this is also planar actually. If we draw the structure of dinitrogen trioxide, this is planar. This is how dinitrogen trioxide looks. This nitrogen and oxygen bond length is 114 picometer. Nitrogen bond length is a little bigger, 186 picometer. This angle is 105 degree, and this angle is 130 degree, and this nitrogen angle bond length is 121 picometer. This is the structure. If you want to prepare this nitrogen trioxide, that is nothing but N2O3. What we can do is you can take nitrogen oxide, which we have just studied, react with N2O4 at a temperature of almost 250 Kelvin. You get N2O3. That's how you prepare N2O3. Correct. Let's draw the Lewis structure of N2O3 now. So we have 2 nitrogens and let's suppose we have 3 oxygens. So the number of valence electron is, there are 3 oxygens, so 3 into 6 plus 2 nitrogen, that is 2 into 5. That is 18 plus 10, that is 28. So we'll use 2 electrons to form this bond. 2, 4, 6, 8. We are done with 8 electrons, so minus 8, we have 20 electrons. 20 electrons. We'll use 6 electrons each on these oxygen atoms. You can watch my video on the Lewis structure, which will give you a deep understanding on how to draw the Lewis structure. So we are left with 2 atoms. Okay, 2 atoms we can put here. So now let's see how much it is. Oxygen has 8, nitrogen, all the oxygen has 8, nitrogen, this nitrogen has 6 electrons, and this nitrogen has 1, 2, 3, 4, 5, 6. Both nitrogen has 6 electrons each. These 2 electrons will pull and form a double bond, and these 2 electrons also will pull and form a double bond. So with this, what we'll get is something like this, and this will have 6 electrons. There will be a single bond here, 4 electrons, double bond, and then one double bond. So this is the structure we'll get for N2O4. Actually, we can draw a resulting structure. So instead of taking 2 electrons from this oxygen, we can take resulting structure 2 electrons from this oxygen. So in this case, we'll get one more structure, and that will be something like this. Correct? This is the structure we get. That is my N2O3, dinitrogen trioxide. The next is nitrogen dioxide, that is NO2. It's very famous. It is a brown gas. This is brown gas, and this is acidic. This is acidic brown gas. Correct? This is NO2, acidic brown gas. Now we'll draw the structure of NO2. Before drawing the structure, let's see how it is prepared. So to prepare this, we use PbNO3(2), and we'll heat this almost 673 Kelvin. What you get is NO2 and 2Pb. Structure of NO2 is something like this. This is my 134 degree, and this length is angle. The distance between N and O is 120 picometer. Let's draw the structure of NO2. There is N, there are 2 oxygen, nitrogen is 5, oxygen is 6, and 6. So 5 plus 6 plus 6, that is 17 valence electron we have. We'll use these 4 to form bond. So we are left with 13. Right? 13, let's put 1, 2, 3, 4, 5, 6 here in the oxygen to form octet. 1, 2, 3, 4, 5, 6 here in the oxygen to form octet. 12 is gone, 1 is left. So 1 will put in this nitrogen. So we are done with electron sharing. Now we'll see this oxygen has completed octet. This oxygen also has completed octet. But this nitrogen has 1, 2, 3, 4, 5 electrons. That is not good. So we can transfer these 2 electrons from this oxygen to this nitrogen. So with this, we'll get shape like this. Correct? So in this case, oxygen has 8. This oxygen has 8 electrons. This nitrogen has 1, 2, 3, 4, 5, 6, 7. That is the best we can give for this nitrogen. Correct? So this will be the structure. Actually, you can say resulting structure. Why? Because instead of taking oxygen from this, electron from this oxygen, we could also take electron from this oxygen. So in that case, you will be drawing, getting some other structure, something like this. Correct? So in this case, we took electrons from this oxygen. So these are the 2 structures we can get for N2O. The next is dinitrogen tetraoxide, that is N2O4. Right? This N2O4, you actually get you to have 2 NO2, it dimerizes to form N2O4, and we'll see NO2 has a good property of dimerizing. It dimerizes to form N2O4. It is colorless solid. Please note, it is colorless and it is solid, or sometimes liquid. It is acidic also. Okay, so this you have N. This is the structure of NO2. And you will take one more NO2, it dimerizes and it will form N, sorry, it will be one more N here. something like this, N2O4. Right, so this NO2 is brown, we have just seen brown gas, and this is my colorless liquid or solid. Right, this is colorless liquid or solid. Correct. So if you see this structure of N2O4, this bond length between N and N is 175 picometer. This distance is 121 picometer, and this angle is 135 degree. 135 degree. So now let's see the Lewis structure of N2O4. Okay, so N2O4, so let's draw NNOOO. N2O4, 2 nitrogen, that is 2 into 5 is 10, plus 4 oxygen, that is 4 into oxygen. Each oxygen has 6 valence electrons, that is 24. 24 plus 10 is 34. So we'll use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons to form bond. So 10 is used, we have 24. Let's distribute this 24 electrons among this oxygen. So we get 1, 2, 3, 4, 5, 6. Oxygen octet is complete. 1, 2, 3, 4, 5, 6. 6, 6, 12. 1, 2, 3, 4, 5, 6, 12, 6, 18. 18 and 6 is 24. So all the 24 electrons are used. All the oxygen octet is complete, but this nitrogen octet is not complete. This nitrogen has 6 electrons. This nitrogen also has 6 electrons. What to do? So we can pull this electron and form a bond here. We can pull this electron and form a bond here. So with this, the structure you will get is something like this. Correct? So this will have 4 electrons now. This will have as usual 6 electrons. This will have 1, 2, 3, 4 electrons. This will have as usual 6 electrons. This all the elements, the octet is complete. Correct? This is my structure. Actually, instead of taking electrons from this and this oxygen, you can take it from 2 oxygen on the same side. So in that case, you will form structure something like this. If you take electrons from the same side, correct? So you'll get structure something like this. So this is again one more resonating structure. So thus we can say that these are the resonating structure of N2O4. The next is dinitrogen pentoxide, that is N2O5. So in this case, the oxidation state of nitrogen is +5. This dinitrogen pentoxide is again my colorless solid. This is also acidic. And to form this, we use nitric acid and react with P4O10 to give 4HPO3 and 2N2O5. This is what we're looking for. Correct? The structure of N2O5 is something like this. Okay, so this angle is 112 degree, and this length is NO is length is 151 picometer, and this NO length is 119 picometer, and this angle is 134 degree. If you want to draw the Lewis structure of N2O5, let's draw this. N2O5. Correct? So how many oxygen? 5 oxygen, 5 into 6. 2 nitrogen, 2 into 5. That is how much? 30 plus 10 is 40. Right? So N2O5 is 40. So let's see how much we can draw for N2O5. So we have to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to form 6 bonds. So 40 minus 12. We are left with 28. 28 we are left with, so we have 1, 2, 3, 4, 5, 6. 24 we can use in these oxygen actually. So let's use this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 we can use, so minus 24. Left with only 4 electrons. Correct? So we are left with only 4 electrons now. So we have to put these electrons. We can put these electrons, let's suppose here in oxygen itself. 1, 2, 3, 4. Left with 0 electrons. Everything is done. Let's see if it is balanced. Oxygen 8, yes. Oxygen 8, yes. This oxygen is also 8. 1, 2, 3, 4, 5, 6, 7, 8, yes. Oxygen 8, oxygen 8, yes. Oxygen is all balanced. Nitrogen, let's see. Nitrogen 1, 2, 3, 4, 5, 6. We want to balance this. So let's take 2 electrons from this oxygen, put it here. This nitrogen 1, 2, 3, 4, 5, 6. Again, let's take 2 electrons from this oxygen and put it here. So with this, what you get is nitrogen with a double bond, oxygen, oxygen, nitrogen with a double bond, and oxygen. This will have 6 electrons, this will have 4 electrons, this will have 4 electrons, this will have 4 electrons, this will have 6 electrons. And everything is satisfied. So this is one of the resonating structure. In this case also, instead of taking electrons from 2 oxygen on the same side, we would have taken electrons from oxygen on these sides also. Then you'll get oxygen double bond here and single bond in this oxygen, so that we can draw more and more resonating structure for this. Okay, so with this what you will get is, if you want I can draw it for you, something like this. Correct. So if you take electrons from these 2 oxygen, from these 2 oxygens, then you will get something like this. Now we'll take some numericals on this nitrogen family. The question is, why NO2 dimerize? So let's see the structure of NO2 first. NO2, right? Nitrogen is 5 plus 6 plus 6. That is 5 plus 6 plus 6. That is 17. Out of 17, we have used 4 to form bond. That is 13. 13, let's use this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1 in nitrogen. So everything is used. Now if you see this nitrogen, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. All the octet is complete. This oxygen also has 8. Octet is complete. This nitrogen has 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5. Octet is not complete. So we'll take 2 oxygen from this, put it here. So what you get here is something like this. Correct. So this oxygen and octet is complete. This oxygen octet is complete. This nitrogen has 1, 2, 3, 4, 5, 6, 7. That is the best you can have. But this is odd valence electron. Now in this case, if you see, this odd valence electron is not stable. So this odd valence electron is not stable. Thus it will dimerize to convert into stable N2O4. So if you see the structure, we had something like this, right? So this was the one, but this is the odd one. So it will react with one more N2O, and then they'll form a bond between these 2, right? So with this, it will get something like this. So now if you see, and if you see the octet, so everything is stable now. All the oxygen octet is complete. This nitrogen 1, 2, 3, 4, 8. This nitrogen also 8. So this is again my brown gas, and this is my colorless liquid or solid. And thus NO2 dimerized. So the main reason was the odd valence electron in NO2. The next question is, what is the covalence of nitrogen in N2O5? Let's draw the structure of N2O5. We have just drawn. I'll not repeat. You can actually use the same one. So now if you see, covalency of nitrogen here is how much? 1, 2, 3, 4. In this case, 1, 2, 3, 4. The covalency of nitrogen is 4 in N2O5. Just draw the structure and see the number of bonds nitrogen has.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.